Greetings and welcome everyone. My name is Qabaqaba Mcebisi. I'm at the University of Fort Hare doing my Masters in Applied Remote Sensing, and I'll be giving a core talk on light and air. Here is our hierarchy of models, and we're at number 2 in our hierarchy of models. This is the content of my core talk. I'll be talking on what is air, composition of air, the atmosphere, what is light, electromagnetic spectrum, the visible light, relationship between air and light, special South Africa, and why South Africa is a special place to study Earth system science. As you have heard from the previous core talk on why the planet is habitable, the planet Earth is habitable, well, it is its position from the sun, its distance from the sun, its size. Well, there are many aspects that make the planet habitable, and the light and air are one of the ingredients that make the planet not too hot and not too cold, which just make it good for human survival. What is air? Air is a mixture of different gases, such as nitrogen, oxygen, argon, neon, helium, which this column shows the constituent, and this column shows the formula of the constituent, and this column shows the percentage of that gas in the air. Air is, as I had said, air is not a chemical composition, but is a mixture of gases, invisible gases, suspended microscopic particles, water droplets, and others. There is a gases exchange between the atmosphere and the Earth's surface, and during this process, there are molecules that are produced and that are destroyed through internal processes. The atmosphere acts as a reservoir for gases. Therefore, it remains constant as long as the input rate is equal to the output rate. The slower the input or output rate, the longer the gas remains in the atmosphere, and the quicker the input or output rate, the quicker the gas dissipates from the atmosphere. And this is a diagram showing of a volcano. The Earth's surface is inserting gases into the atmosphere. I'd like us to appreciate and understand the following, that the concentration of greenhouse gases into the atmosphere influences processes such as the greenhouse effect, global warming, carbon dioxide and chlorofluorocarbon concentrations in the atmosphere, aerosols, and acid rain. The atmosphere consists of different layers such as the troposphere, stratosphere, mesosphere, thermosphere. The troposphere is where weather forms, and this is a distance of 16 kilometers from the Earth's surface, and it contains about 75% of the atmosphere. The troposphere extends 80 kilometers from the Earth's surface in the north and the south poles, and about 16 kilometers in the equator, and it gets colder with altitude. The higher you go, the colder it becomes in the troposphere. And the troposphere is divided to the stratosphere by the tropopause. And the stratosphere is at about 16 to 50 kilometers above the Earth's surface. And the ozone layer floats to about 22 kilometers above the Earth's surface. And temperature rises in the stratosphere, and the stratosphere contains about 20% of the molecules in the atmosphere. The stratosphere and the mesosphere are divided by the stratopause. The mesosphere is at about 50 to 85 kilometers above the Earth's surface, and in the mesosphere, this is where shooting stars blaze. Space debris begin to burn as they enter the mesosphere. Temperatures drop rapidly in the mesosphere, as you can see the red curve. They can drop to at about negative 95 degrees Celsius. And the mesosphere and the thermosphere are divided by the mesopause. And the thermosphere is at about 80 kilometers to 640 kilometers above the Earth's surface. And this is where temperatures rise. And even though the air is thin in the thermosphere absorbs most of the solar radiation. Coming to light. As we know the nature of air, which is it is a gas, and the nature of light has puzzled mankind for centuries. Visible light behaves both as a wave and as a particle, but quantum mechanics tells us that light can behave simultaneously as a particle and as a wave, but that is yet to be proven. And I have said earlier that the nature of light has puzzled mankind for centuries, which is they don't know if it is a wave or it is a particle, hence the wave particle duality. For many years, scientists have debated the nature of light. Sir Isaac Newton proposed the idea of light as a particle, but that idea was opposed by other scientists, with Huygens citing that light was a wave and it traveled in a direct line, vibrating up and down perpendicularly to the direction that the light traveled. And for many years we have used that model of light as a wave until the 20th century, when Albert Einstein reintroduced the particle of light, which is the photon. He believed that light behaved both as a particle and as a wave, and he demonstrated this using the photoelectric effect, which states that when incident light hits upon a metal, it emits electrons. He argued that if light acted only as a wave, then its amplitude and wavelength should affect the number of emitted electrons. This is a law of conservation of energy. And moving on from that, what is light? Light is the electromagnetic radiation within a certain portion of the electromagnetic spectrum, and it is visible to the human eye and is responsible for the sense of sight. Visible light consists of red, green, and blue colors, which are the fundamental colors where all other colors are composed from. Other colors that we see are composed from these three basic colors, which is red, green, and blue. Here is an illustration showing the visible light within the electromagnetic spectrum, which starts at 400 nanometers to 400 nanometers, which are high long wavelengths, to red, which are long wavelengths, which is red, 700 nanometers. Visible light consists of reflected and emitted radiation. Reflected radiation is the radiation that is reflected back into the atmosphere by the Earth's surface, and it consists of shorter wavelengths with it. And emitted radiation is the energy that is absorbed by the Earth's surface, and it consists of longer wavelengths with it. This diagram illustrates the relationship between the wavelength, frequency, and energy. And wavelength has an inverse relationship with frequency and energy. The shorter the wavelength, the high frequency or high energy it has. The longer the wavelength, the lower the energy or lower frequency it has. And hence radio waves, which are long wavelength, they are harmless, and because they have low energy and low frequency. And gamma rays, which are short wavelength, they are harmful because they have high frequency and high energy. The interaction between the radiation and the atmosphere. There are many processes that happen between the radiation in the atmosphere before radiation hits the Earth's surface. And the atmosphere affects this radiation in many ways, and it varies based on the properties of the radiation, which is the path length, the magnitude of energy the radiation possesses, the atmospheric conditions, the wavelength. Have you ever wondered why skies were blue and sunset were red? Well, it is because of scattering of light in the atmosphere. Scattering is when particles in the atmosphere interact with electromagnetic radiation and cause it to be redirected from its original path. And this depends on the wavelength, the abundance of particles, the distance the electromagnetic radiation must travel, the the size of the particle. There are two types of scattering, which is Rayleigh scattering and mere scattering. Rayleigh scattering is responsible for the blue skies and the red sunsets, and mere scattering is responsible for the white or gray clouds. Rayleigh scattering causes blue skies during the day and reddening of sunset during when the sun is setting. Rayleigh scattering is scattering of radiation by small particles which are much smaller than the wavelength of radiation. And when these particles scatter the radiation, they cause diffuse sky radiation, which is responsible for the blue skies. Diffuse sky radiation is basically solar radiation reaching the atmosphere after being scattered by molecules in the atmosphere. Well, this means that the shorter wavelength, which is blue, is scattered more strongly than the longer wavelength, which is red, and this results in the indirect blue light coming from the skies. The interaction of radiation with matter. As you can see, this diagram shows the arrows that come, which says label I, is the incident radiation upon the target, with the leaf being the target. And there are three possible types of interaction with the radiation, which is R, reflected from the target, which is the leaf is the target. A, absorption by the target, is the radiation is absorbed by the leaf. And T, which is transmission through, which is the light passes through the leaf. And in remote sensing, we are most interested in measuring radiation that is reflected from the target. And as the light is reflected from the target, the sensors capture that reflected energy, and they can make sense of the color of that object. Hence, the satellite images that we can see. Absorption of light in the atmosphere. Molecules in the atmosphere absorb energy at various wavelengths. These are mainly the ozone, carbon dioxide, water vapor, dust, and this results in a loss of energy reaching the ground. But certain wavelength ranges of the electromagnetic spectrum allow energy to be transmitted differently, and these are known as atmospheric windows. And as you can see in the electromagnetic atmospheric windows, that visible allows most of the energy to pass through. The near infrared also allows most energy to pass through. This is an illustration that shows the rest of the other regions of the EMS and how they allow energy to pass through. Now that we have talked about light and air, we come to the most important process that makes our planet habitable, which is the greenhouse effect. The greenhouse effect is a result of the interaction between radiation, the atmosphere, and the Earth's surface. When the sun hits the Earth's surface, most of the radiation is allowed by the atmosphere to pass through, but most of the radiation is reflected into space. And the reason the most radiation passes through is that the atmosphere is transparent to visible light, which is short wavelength. And when this radiation arrives at the Earth's surface, some of the radiation is reflected into the atmosphere, and most of the radiation is absorbed by the Earth's surface. This radiation that is absorbed by the Earth's surface is converted to heat energy, causing the emission of long-wave radiation, which is the infrared. The Earth's surface absorbs this radiation that was visible light, which was short wavelength, into the surface, and it absorbed this and it emitted it as a long wave infrared, which is infrared radiation, into the atmosphere. And when this infrared radiation, which is long wave infrared, as I had said earlier, that long waves arise from emitted radiation. The radiation is emitted by the Earth's surface now into the atmosphere, And when this infrared radiation arrives in the atmosphere, it is trapped by the greenhouse gases. It is basically trapped by the hydrogen molecule in that is in methane, in the water vapor, and also other greenhouse gases. And when this hydrogen molecule traps this infrared radiation, it vibrates in a speed way, making it more excited. And then when it vibrates, it reflects that infrared radiation into the atmosphere, into space, making the planet to be warmer and survivable. Hence, the greenhouse effect is one of the most important processes that make our planet habitable. And coming to why South Africa is a special place and that you can study as system science. South Africa is special for its sunsets. In South Africa, we have the north, the west, and the east. And these two regions in one country have different sunsets. In the east, the sun sets at past 6, and in the west, it sets at about past 7 to 8. Hence, you can see this beautiful thing within one country. You don't have to go to another country to experience such a natural thing. Now, in concluding my core talk, I talked about air and light and other things. Air is a mixture of gases. The atmosphere has multiple layers. Light behaves both as a particle and as a wave. And radiation can be scattered, transmitted, reflected, and in the atmosphere, the sky is blue, and white consists of white clouds that result in different wavelengths being scattered by particles in the atmosphere. And the atmosphere is responsible for the greenhouse effect, the atmosphere, the radiation, and the earth. And the earth, the light, and air is crucial for our next topic, which is situating atmosphere, because radiation hits the earth surface at different angles. Hence, that air is circulated from the equator to the south and to the north poles. But that you will hear more of it on our next talk. Thank you very much from me.